All right, so today we are going to be looking at lesson 23.1, which is the law of sines. So we are going to be continuing our study of our trig ratios, except for now we are going to apply them to non-right triangles. So in the previous activity, we looked at sine, cosine, and tangent as being ratios of your opposite to hypotenuse, adjacent to hypotenuse, and opposite to adjacent. But in this lesson, we are going to use that to discover and develop this law of sines. So we start off. The location of a fire spotted from two fire observation towers can be determined using the distance between the towers. So that'd be this distance here, and then the angle that the towers make with the fire. So if we know those pieces of information, we can find this location. And this process is known as triangulation. So some of you may have seen a TV show or a movie that actually uses triangulation. They have computers that do it in the TV show or movie, but you use triangulation in surveying, navigation, cellular communications. So most commonly, you're waiting for someone to make a phone call. As soon as they make a phone call, they're going to trace where that phone call is to find the person to then go capture them. That is triangulation. So that's what this is. We're looking at it mathematically, not using a computer, but computer systems work through that, dealing with surveying and navigation and other different ways. So something to note on this one. You don't actually have to know the distance from point A to point C. We don't have to know this distance. If we know the distance between two of them, and then we can find these angles, we are able to find both this distance and that distance. So we're going to start by developing this law of sines. So it says begin with our triangle and draw the altitude CD from vertex C to AB. So remember, your altitude is perpendicular from a vertex. So they said start at vertex C, and then we are going to go perpendicular to point D. And then they said label the altitude H. So this is H. And then it says what two right triangles are formed. So do you see we have this triangle here and this triangle here. What are those two? Well, the one that I traced in black, triangle ADC. And the one that I traced in green, triangle BCD. And the order doesn't matter there. They were just asking you to name them. You can use those triangles that we just formed to write some trig ratios. So we're going to use our trig ratios that we were just looking at. Sine, cosine, and tangent. Specifically sine of A. So here is our angle A. Sine of angle A is opposite over adjacent. So opposite angle A is H. I'm sorry, over hypotenuse. And then our hypotenuse is this side length, which is B. Then with the green triangle, we're looking at angle B. So again, we're dealing with sine. So the sine of angle B, opposite, which is H, over the hypotenuse, which is A. So that gives us these two equations. Step 4 says, solve each of those equations for H. So if you look, I'm trying to get this just H over here. So I need to multiply by what's in my denominator, the B. Same thing over here. I'm going to multiply by the B. So that gives me H equals, I can write B times sine of A, or I can just say B sine of A. You can write the multiplication symbol or not. That's up to you. Then looking here, this is our H. So again, we're going to multiply by A, and we're going to do that on both sides. And that gives me that H is equal to A times sine of B. Now we want to set the values for H equal to each other. So both of these are equal to H. So I can say B sine of A, or B times sine of A, is equal to A times sine of B. And then the last step is to try and complete this statement. So what we are trying to do is to get the left side of the equation to just be sine of A. So there is a B next to it. So we need to divide by B. And if I divide by B, I have to do that over here as well. And so I'm going to come over here to the right. That gives me sine of A equals A sine of B over B. And then if you look at this statement we're trying to complete, it has a sine of B in the right side. And I have an A over here with the sine of B, so I need to divide by that A, and I need to do it on the left side as well. So now I have sine of A over A equals sine of B over B. And if you go to the next page, they show you, they tell you, in a similar way, you could show that sine of A over A also is equal to sine of C over C. And sine of B over B equals sine of C over C. Basically, you could show all three pairs would work. Be the similar sort of method as what we just did. We're not going to go through them. If you want to, you're welcome to try those. But deriving those is called the law of sines. So they say, here is the formal statement for the law of sines. For any triangle ABC with side lengths AB and C, this statement holds true. Sine of A over A is always going to be equal to the sine of B over B is going to always be equal to the sine of C over C. So something to note here. This is called the law of sines. This does not hold true for cosine or for tangent. This is only for the sine. And I want to flip back and look at the previous page and make sure you see the connection between the capital A and the little a. So I'm going to erase all of my drawings. Angle A and side A are opposite of each other. Angle B and side B are opposite of each other. And angle C and side C are opposite of each other. So you don't have to specifically use A, B, and C in this law of sines. However, you do need to make sure that your opposite angle and side are in one ratio. That's a pair, an angle and a side. That's a pair. You need to make sure that pair is in the correct position. So let's look. Fire spotters at station A and B notice a fire at location C. So our fire is here. What is the distance between station A and the fire? So we are trying to go from A to the fire. So what we're going to be looking for is B. The reason they don't just say find B, they're trying to get you to use the word problem to figure out what you even need to look for. So the first thing you're going to want to do, pick an angle. 42 degrees. The sine of 42 degrees over angle A. Side A. Because that side is opposite angle A. That is going to be equal to, pick another angle. We have angle 44. So the sine of 44 degrees over the side that is opposite that is B. Then the third angle, angle C. The sine of angle C over the side opposite it is 15. It is C, but they told you it was 15. So that is the very basis of what they gave us. And from there, we can go further. After you set up your ratios, you want to see which one has both pieces of information filled in. So the first ratio has an A, the second ratio has a B, and the third ratio has a C. So that's not helpful. None of them have both of their numbers filled in. So we need to look back at the problem. Is there some other information that I could find from this figure? And there is. Some of you may have already noticed it. Angle C. Since we know angle 42 and angle 44, we can say 180 minus 42 minus 44, and then angle C would be 94 degrees. So some of you may have already noticed that angle C is actually 94 degrees. And that's great. If you notice it to start with, go ahead and fill it in. So now we have one ratio that has both of our numbers, the 94 and the 15. So we are definitely going to want to use that one. Then other one that we're going to want to use, we said we were looking for B. So we want to use this ratio. And that will create this proportion. Sine of 44 over B equals sine of 94 over 15. So, like we were doing in the previous activity, solve your trig, sine of 44 and sine of 94 using your calculator. And so I get 0.695 over B and 0.998 over 15. And from here, you're going to cross multiply. So B times 0.998, 0.998B, and then 0.695 times 15 is 10.425. And then if you're solving for B, you're going to divide by 0.998. And so 10.425 divided by 0.998 gives you 10.445. And they don't specifically tell you what to round to, so let's just go to one decimal place, the tenth. This does not round up, so we leave it as 10.4. And our units are kilometers. So that's our distance that they were asking for between A and the fire. So that's one way you can do it. If you look here, they showed leaving them as sine of 44 and sine of 94 and not actually finding the decimals, and they kept them until the very end. And if you want to do that, that is fine. You can do it that way. You just got to make sure you're careful with your calculator. All right, so let's look at the next example. They tell us that we have boaters located at points A and B, and then we have a lighthouse location at C. What is the distance between our boater at B and the lighthouse here at C? So we are looking for this distance. They don't give you a variable there, but you can pick whatever you want, or since it's opposite angle A, you can label it side A. And same thing over here. This is angle B, so if you want to label it angle or side B, since it's opposite angle B, you can do that. That's up to you. You can pick random variables or use based on the angles that they give you. So the first thing you're going to want to do is set up your ratios. So first, pick an angle. One of the angles is 48 degrees, so you can say the sine of 48 degrees, and the side opposite is a, which if you want to use a different variable, you can. Another angle is the 55 degrees, so the sine of 55 degrees, and the side opposite is B. Then our third angle, they did not give it to us, but since we have two of our angles, we can find it. And it's going to be a 77 degree angle. So the sine of 77 degrees, and the side that is opposite it is 1.5. So pick your ratio that has the two numbers filled in, which is going to be this third ratio, sine of 77 over 1.5. And then we had already said that we were looking for this length, which we labeled as A. So that's going to be using this ratio. So sine of 48 over A is equal to the sine of 77 over 1.5. And so if you want to see what it looks like without using the decimals with your calculator, like what the book was doing, I'll show you that. So take A, and you can multiply it by sine of 77, so just A sine of 77, and then 1.5 times sine of 48. And then if you're looking for A, you're going to divide by sine of 77 on both sides. So that's if you want to do it like the book showed you. The other option is to actually make the decimals. So come in here, sine of 44, or 48, is 0.743 over A, and sine of 77 is 0.974 over 1.5. And so then you would cross multiply, and so we'd have 0.974A, and then 0.743 times 1.5 is 1.1145, and then you divide by 0.974, and if you round to the tenth, because they said round to the nearest tenth, so one decimal place, you have 1.1 kilometers. So you should get the same answer whether you used this in your calculator or whether you did it this way. And either way is fine. So now let's look at number 5. They want us to show that the law of sines is true for a 45, 45, 90 triangle. So the first thing you're going to want to do is actually draw a 45, 45, 90 triangle with leg lengths of 1. So we have a 45, 45, 90 triangle. The leg lengths are 1, it says. And then if you remember from the 45, 45, 90 triangles, the hypotenuse is multiplied by the square root of 2. So 1 times the square root of 2 is just square root of 2. So our hypotenuse is square root of 2. If you set up the law of sines, pick an angle. You have a 90-degree angle. Sine of 90 degrees. The side opposite that is a square root of 2. Pick another angle. You have a 45-degree angle. So sine of 45 degrees. The side opposite it is 1. And then you have another 45-degree angle that has the side opposite it that is also 1. So you don't have to write it twice, although you can. So then use your calculator. Sine of 90 is 1. And then 1 divided by square root of 2 is 0.707. And then sine of 45 is 0.707. Divided by 1, you still have 0.707. And so those are the same numbers. So is this true for a 45, 45, 90 triangle? Yes, it's still going to be true. It still works. So you can use this on a right triangle if you would like to.